motion diagrams. Because remember what I said, we ultimately need a picture. So I'm going to use a motion diagram. We will use motion diagrams to describe the motion. Okay, so one of the things that I want to do here is that I want to think about what a strobe light does. So a strobed image is a series of flashes and camera pictures. So every time something flashes, you get an image. Strobed images show the history of an object's motion. And what I'm going to do here is that I'm going to show you an image. So I found this online. And since I'm not selling my notes, it's not considered piracy. And there's my strobe image right there. And what you're seeing here is that there's a boy right here, right? And you can see that he's running across the screen. And what you're finding here is that that represents the history. So what we need to do here is that we can get two pieces of information from this image, right? We can get two pieces of information. Well, one, we know that it's a strobed image. So that means that the number of images tell us the time. So what we'll see here is that if I look at the boy here, let's say that this is the boy right here. And let's say that this is where there's a flash right here, right? So here's a flash. And then the very next moment, the boy has slightly moved. And then this is the second flash. And so what that tells us here is that I can measure the time between flashes here. So this will be the time between flashes. And so what I'll say here is that we're going to standardize this time. And we're going to say that between flashes, we're going to say it's 1 second. So then I count the number of images. So if I say between each flash, it's 1 second, then I could see that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it took the boy 9 seconds to run across the screen. In reality, the flash probably took a 15th of a second. So it's a very, very, very tiny amount. But we're going to standardize it. But there's another piece of information. From the strobed image, we can get distance. And the reason why is that we could take a meter stick and literally place it down here at the bottom to show how far this boy traveled. So what we're going to see here is that we're going to say that delta x then is going to be the distance between each flash that the boy moves. So now to get information from this thing, what we do here is that, so to get information of motion from the image, we plot the center of mass locations. And the center of mass of the boy is typically the belly button. So what I'm going to do here is that I'm going to take this image. Now note, I'm going to delete this image in a moment. So I'm going to show you how I get that information. So what I'm going to do here is that I'm going to pick one point of the boy, and I'm going to say that the point that I'm going to pick here is going to be his belly button. So I'm going to try to pick his belly button on every image. So let's look at that. So I'm going to say, here's one. Here's one. And of course, I'm guessing right here. And then I'll stop right here since I don't see the other one. So now what I'm going to do is I'm going to delete this. But before I delete this, note that this is point 0, 1, 2, 3, 4, 5, 6, 7. So now I'm going to delete this image, and those dots represent the history. So now what I'm going to do here is that I'm going to move it up here. Now, because I have this, look what I find here. If I look at the dots, let me try to move the dots onto a line here. And it looks like the dots are about 2 squares every single time here. So these dots are equally, ooh, no. I want to write this big. Equally spaced. Are they exactly equally spaced apart? Well, it's hard for me to tell because it was hard for me to judge where his belly button was at each time here. But that's what it means here. So you could see here is that now this is the history of the motion of this boy right here. Let's start analyzing this thing. So the first thing I'm going to say here is that this motion diagram is of constant velocity. Why is it of constant velocity? Because the boy is moving at constant speed and constant direction. So what do I mean by that? Well, let's define the direction. So if I set my direction like this, and I call that the east direction, that boy is always running to the east. So we know the direction all the time. And of course, it's the east. So I got half of the velocity now. Now I need to understand about the speed here. So speed is what? It's distance divided by time. But if you look at those distances, they look like they're roughly equally spaced here. So we're seeing that we have equal spacings. Between dots. So that tells me here is that this is constant speed. So, but let's analyze this a little bit better here. So what I'm going to do here is that I'm going to pick my dots here again. So I'm going to go, but this time I'm going to be really clear that I have equally spaced dots. So again, here's 0, 1, 2, 3, 4. So what do we mean by speed 1? So check this out. The distance between 0 and 1, that distance is the distance between 0 and 1. That distance between 0 and 1 tells me that I have a speed v1 at point 1 here. In other words, when I write v1, it's equal to that distance divided by that time. So speed v1 is associated with the distance prior to that. And then if I look at speed v2, so the speed at v2 is about distance between 2 and 1. So when I go and I look at the speed 2, which is this speed right here, it's always about the distance prior to that. And if I look at the next speed, v3, I see here that that's about speed v3. So if I look at v3, it's about the prior distance, and that tells me that v3 is always associated to that prior distance, which then looks like this here. So if I was to write this out, oh, I'm out of time. Motion. And when we were looking at motion, we wanted to start talking about what does velocity look like in that motion. So we started with a diagram. And when we looked at that diagram, we showed that the strobe image showed a history of an object's motion. And one of the things that we saw here is we see that from that strobe motion, we get two pieces of information. We get not only the distance traveled, but the time interval. And we were saying here is that all of our time intervals are going to be 1 second. In reality, that's not the case. Cameras are much faster. And if I remember correctly, I think cell phones are, I believe it's 0.15 seconds is every time that it actually flashes. So what we're doing here is that if I have constant velocity, we showed that we had equally spaced dots. Those equally spaced dots told us that we were moving at constant speed and constant direction. And so what we saw here is if the dots are equally spaced, and we looked at the picture of, let's say, that boy running, we saw that the boy was running to the right, so therefore, that's in the east direction. So then if I have a slower speed, then the arrows are shorter. That's what that means. If I have a higher speed, then the arrows are longer, but they're still pointing in the same direction. Therefore, slower speeds have smaller distances between dots, and you can see that each of the length of these arrows is the same, and I tried to draw the symbol V for velocity to be exactly the same. Why is this velocity slower? Because it covered a small distance in that time. If I have a higher velocity, then that means here is that the spacing between the dots must be larger. So when I write out the equation, you could see that the green arrows are longer because they cover more distance in the same amount of time. That's what we mean by slower versus faster. Next, what we did here is that we started to touch on constant velocity, changing velocity. So when I have change in velocity, there are two ways to change velocity. Now, the important piece here is this, is that if the velocity vector changes in any way, then velocity is changing. So if the arrow changes in any way, now we know that we have velocity. And so here we go. Let's write it out. So the first case is that we're going to be talking about a change in speed while having constant direction. So the first situation that we could think about is speeding up. So if I'm thinking about speeding up, that means that if I'm getting faster as I speed up, that means that the dot spacing has to increase. So speeding up means that the dots must be getting farther apart. So if I start to draw out my situation, I'm going to go, okay, here's the spacing between there. That's 1 square. And then let's say that now it's gone to 2 squares. And then it goes to 3 squares. And then it goes to 4 squares. You could see that the dots are getting farther apart. Now let's start drawing our vectors. Look at this distance here. That distance is a small distance. So we know that the dot spacings and time are going to be exactly the same. So then that's what that tells me right there. So I'm going to come in and I'm going to draw my velocity right here. Now I look at the next spacing. If I look at the next spacing here, you could see that that's farther. That means that my x should be larger. Okay. So then when I look at my velocity, that velocity vector should be drawn longer and bigger. And if I look at my next interval, you could see that that's even longer. So then this speed is covering a bigger distance. So that means that this velocity must be getting longer and higher. So I could then keep going along that direction here. And if I do that, you could see that this is even longer still. And so therefore, that has the biggest distance between dots here. So then if I look at my velocity here, this velocity should be even larger, indicating that I'm getting faster or speeding up. I could be in the other situation where I'm going to be slowing down. So if I'm thinking about slowing down, then the dots must be getting closer together. So if I follow the same procedure as before, what am I seeing? Well, I see a dot here, and then I'm going to go, let's say 4 squares, and then the spacing is being reduced. So you're seeing something like this. So as before, I'm going to draw my vectors here. And what you're seeing here is that what's happening here. This guy is the longest. So then what happens to the next one? It's getting smaller. I think I need to draw these bigger. So I'm going to go big, smaller, and then I'm just going to continue to get smaller. And you could see here that I could even get to the point where I'm not moving very fast at all. And then at this point, I could say I actually stop at this point right here. Clearly, you're seeing this. So if I now look at two of these, this is a big distance. This guy here is a tiny distance, but when I look at my time intervals, this should be exactly the same. Therefore, that's why I have a high velocity there, and that's why I have a low velocity there. So let's look at this example. Again, I have a strobed image, and let's look at this thing. I think I'm gonna actually put it on the side over here. Oh no. I think I put so what I did here in this image here is I went ahead and I tried to put red dots of this diver right where his waist is at. And so what you're seeing here, if I look at the dots as they're moving down, okay? So let's see if I can actually show this nice and clean. So look at the spacing here. That spacing is small between the dots. But if I look at this spacing here, you could see here that the spacing is big. Now, since this is a strobe image, the time between each of the dots is the same. But what you're seeing here is that I'm going to get a big velocity here because I travel a big distance, whereas here I have a small one. So the strobe image is really showing very clearly how we use these dots. So what I'd like to do here is I'd like to go in and see where else we're at. And so what we'll do here is that we'll go to the next piece, and I also have an image for that piece. So let's go look at that. So I'm going to come in here. And now I want to talk about changing direction. So here is our second one. And now we're going to look at constant speed. Changing direction. And whenever you see this, this is what we mean by turning. So this situation is turning. Now, so suppose one is driving along Highway 1 towards the fishhook. Now, if you read what the speed limit is on the fishhook, it has a speed limit of 20 miles per hour. So if you're an upstanding citizen and you're driving the speed limit, that means every time you go around the curve, you should be driving a maximum speed of 20 miles an hour. So if you're driving 20 miles an hour, this implies here that you should have the spacings between the dots should be the same. But the big difference is that the steering wheel is constantly changing the direction of the car. So if it's constantly changing the direction, you could imagine if you're on the fishhook. So the first thing I got to do is I got to draw equally spaced dots. So let's do that. So you get in, and then we're going to say, okay, you're equally spaced, and now you're in the turn. So if now you're in the turn, I'm trying to draw all these dots to be equally spaced. And so that means here is that as I go from this point to that point, that speed is the same. But then I have to turn to stay on the road. And I have to keep turning to stay on the road. So I'm constantly changing the direction of these arrows. But I'm trying to draw these in such a way that the lengths of these are always the same. So the speed here is a constant, but the direction is changing. Therefore, I am changing my velocity. So to show you what do I mean by that, we can analyze certain pictures to get a sense of what's going on here. So here's a picture of a woman that's on a parallel bar. And I'm looking at this thing here. And what I did here is that ahead of time, what I ended up doing here is I put a green dot on her waist. And what you can see here is that as she is swinging down, look at the spacings. The spacings are larger. So that means here is that if I look at the spacing from here to here, this spacing is very big. So that means that right here, I should have a big velocity. Now, if you look at the spacings as she's going upwards, look what happens here. If you look at this spacing from here to here, when I look at the dots, that distance is not very big right there. If that distance is not very big, then that means that the speed here must be slower here. So this tells me that that has a changing velocity, right? This has a changing velocity because in this case, you're changing speed, and direction. You're changing both. And you know what? I'm going to move this over here just a little bit because I want to conserve space. I have another image that I want to show you. And this is the image that I should have started off with. And for some reason, I started off with the other one. This is more in line with this example right here. So why is it more in line? Well, if you look at this thing here, there's this bat and it has a blue flasher and a red flasher. Okay, it has a blue and a red flasher. And what you're seeing here is that we want to analyze the backswing And then we want to look at the front swing. So this is a bat. So what you're seeing here is that look at the dots for the red flasher. So if I look at this thing here, I'm asking you to look at these dots right here. Look at the spacing of these dots. These dots here are equally spaced. That means as the bat moves backwards for a period of time, it's moving at a fairly constant speed. So this is a constant speed, but changing direction. And I can do the exact same thing with the blue dots here. If you look at the blue dots, there's a period of time where those dots are equally spaced. Excuse me. But now what you're seeing here, as the bat goes forward and you're swinging this bat, look at what's happening to these spaces now. If you look at these spaces now, those dots look like they're equally spaced as well. Now note that there's a period of time where you see the dots are really close together and then they're getting farther apart. But once that's because you're speeding up there. But if you look at these dots right here, they look like they're equally spaced. So because of that, we can then say that it's constant speed, but it's changing directions.